Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's challenging level puzzle, and it's called Pharos by Nicholas Duhale. And here are the rules. We have normal Sudoku rules apply, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. The sum of the digits along an arrow is equal to the digit in the connected circle. So, for example, if we had, say, 4 and 4 here, this digit would have to be 8, because the digits along the arrow must sum up to the digit that's in the attached circle, and 4 add up to 8. So that's an example of how arrows work. We have a digit in a circle indicates the total number of digits it sees in its row and column, which are strictly smaller than itself, where digits larger than itself block vision. Okay. So that means if this were 8, it would see 8 cells in the same row and column, which are smaller than itself in the same row and column. So that means we could have, say, a 9 here and a 9. No, that doesn't. Yes, that works. So basically, you could have a 9 here and a 9 here. And these digits, this 8 would see these 3 cells here. And it would not see any other cell in the row because it's blocked by the 9. Because these 3s have to be smaller than the 8 because we already have the 9 counted for here. And 8 is the second largest number. And it sees 1, 2, 3, 4, 5 cells in the column, which is strictly smaller than it because the 9 blocks all vision from these cells. And these cells would be smaller than the 8, but again, they are blocked by the 9 because the 9 is larger than it and it blocks vision. So this is an example of how the digit in the circle could work. And finally, the final rule is each circle contains a different digit. So that means every circle in the grid must have a different digit in it. So we cannot have another 8 in these circles because we have an 8 already in that circle there. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. We have 1, 2, 3, 4, 5, 6, 7 circles. That means we could have technically a 2 here. One obviously can never be in a circle because you'll see no digits that are going to be smaller than it, that are strictly smaller than it. 2 could see 2. 3 could see 3. So basically, these are the digits 2 through 9, possibly. We are missing 1 digit from that, though. Interesting. Oh. So this digit is necessarily... Okay, so all the digits which have the arrows in the same... The cells on the arrow be in the same row, column, or box are guaranteed to be 3 or higher. So these have to be 3 or higher. This could be a 2 here, technically. And it could be 2, 1, 1, if that's the case. These 2 digits are guaranteed to be smaller than this one. So here we have guaranteed smaller for then these 2 for that. This one's guaranteed smaller than that one. This one's guaranteed smaller than that one. This one's guaranteed smaller than that one. This is guaranteed smaller than that. Same with that. So this doesn't really help us much because they're not in the same row or column. Okay. Can this actually ever be 3? If this is 3, that would mean 1 and 2 are here to add up to it. These digits would have to be greater than 3. Both of these, because 1 and 2 are only here in this box. So that means in this column, we would not see 3 cells that are in this row and column. We would not see 3 cells. This circle would not see 3 cells that are larger than it. It would only see 2 at most this way. And then it's blocked by vision this way, if that's the case. So this cannot be 3 here. Oops. This could still be 6, though. This has the same problem. If this is 3, these are 1 and 2. This is obviously greater than 3. This is greater than 3. It would not see more than 3 digits. It would see only 1 digit smaller than it. So this can't be 3 either. Can this be 4 either? So this is the same problem here. This can't be 3 because, again, this would be 1 and 2 forced to be there. And it would not see 2 digits that are smaller than it. It would just see 1, right? It'd see 1, then be blocked here, and it would see nothing here because it would immediately block there. Can these be 4 in the corners either? I think the answer to that is no. So actually, this can't be 3 for the same reasoning. If this is 3, this is a 1-2 pair, and that means that this vision is blocked in each of these cells because these are all bigger than this cell here. So this can't be 3 either. I think this could be 3 because you'd have 1 and 2 there, but you could have 1 and 2 going this way also. And it would see 1, 2, 3 cells then possibly. What about 4 in the corners? If this is 4, this becomes 1 and 3 here. It could see, it would then be blocked. So it could go extend here and then see 3 different cells here, which are smaller than it. But it would not see any other cells here because this would be 1, 2. This would be 1, 3. That would be 2. And then the rest of the digits in the box are bigger. So then this would see 0 cells in the column and then only 3 cells at most in the row. So this cannot be 4 here. And that's the same reasoning there. This, however, could see 4. If this is 1, 3, then it has 2 there. So if you have 4 there, 1, 3, you could have 2 there, and it would see that digit. It would not see any cells here, but it could see 3 up to here. Or 3 this way, if that were the case. So this could be 4. Can we see 5 in the corner? Can this be 4? No, because if we have 4 here and 1, 3 here, the problem is... Okay, so another problem is that these add up to, at most, 8 and 9, which is 17 for these digits here. Because they add up to 17. Well, one thing we know is that of these 4 digits, at least two of them have to be 4 or lower, right? Because if they aren't, then the problem is that these would be one of these pairs would be 5 or 6 at minimum, which adds up to greater than a digit. Okay. Does that help us? I don't know. Let's continue with the corners. 5. These digits are obviously smaller than it. You could have 1, 2, 3, 4, 5 digits that are smaller than it there. That are potentially possible. So 5 could actually work in the corner. Yeah, that is potentially possible. Okay, so that's not too helpful. Yeah, the issue though, if this is 4, this is 1, 3. 2 would have to be one of these digits here. So 1, 2, and 3 could not be here. So then this would not see those cells. I guess you could see the 2 here and then 1, 2, 3 there. That is potentially possible. So this could actually have 4 there. It's probably pretty unlikely, though. Hmm. These are both smaller than this. Guaranteed. That doesn't help us much. Oh. You cannot have a 9 in a circle. It's always going to see... Yeah, you can't have a 9 in a circle. Because if you have a 9 in a circle, the problem is every single digit in the row and column is going to be smaller than it. So then it shouldn't be 9, it should be essentially 17 for every one of these. So therefore you cannot have 9, therefore these must be the digits 2 through 8, because we have 7 of them. And the only one we know then has to be 2. So this has to be 2, which makes that 1 and 1. This is obviously smaller than that. We have to have a 3 here. So one of these is guaranteed to be a 3. The 2 sees the 1. It obviously does not see any of these other digits. This cannot be a 1, so it obviously can't see any of those digits. So then it must see 2 here and 1 here. Well, so then it does not see any of the rest of those digits, so the 2 is satisfied. Okay, so 1 is seen by everything. So we'll just mark that as that. This can no longer be 3. If this were 3, this would be 1 and 2 here. But obviously this can't be 1 or 2 because of the 1-2 pair in the column. So this can't be 3 here. Which means the only place for 3 in the circles has to be here. So this is 3, which makes this a 1-2 pair here. This is, at minimum, 3 and 4 here. It's either 3, 4, or it's 3, 5 here. And with a guaranteed 3 being here. So this sees 1 and 2. These digits cannot be 1 or 2, so it can't be seen any more of these. This is smaller than that. It must see one small digit here, which is 1 or 2. And then it cannot see any of the rest. So this cannot be 1 or 2 here. Okay. So that's satisfied for that. This is then 3 and 4, or 3 and 5, which adds up to 7 or 8. Okay. We don't know. This cannot be 1 or 2, so this is at least 3. And again, it could go up to 7 here because this adds up to 8 at most. This could be 1 through 5 there. So actually, this sees all 3 of these, and they're definitely smaller. 2 has to be one of these 2 digits here. So we have 2 either here or here. This cannot be 1, 3, because if this were 1, 3, that would add... We already have a 1 in the box. So it cannot be 4. It can't be 5, because again, we can't have 1 in the box, so it can't be 1, 4, and it can't be 2 and 3 here. Remaining digits of this row 6 are 4 through 9. 9 obviously can't be here. 8 can't be here. 7 can't be here, because this could be 2 at most. So this can't be 5 either. It has to be 2 and 4 at minimum, which adds up to 6. We could have a 3 here. We cannot have 4 here. 4 and 5 would add up to... yeah, not a big number. Anyways, what do we have left? What digits can be in the circles? We need a place for 4. And this is the only one for it. So this has to be 4, which makes this 1 and 3 adding up to it. That eliminates 4 in the rest of the row. So this can't be 4 here. Therefore, this is 2 and 5 at minimum, which means this is 7 or 8. We have a 7, 8 pair in the circle, so these cannot be 7 or 8. They must be 5 or 6. Okay. This cannot add up to... cannot have a 1 in it because of 1 in the column. So this has to be 2 and 3. No 3 here because of 3 in the row. Or 2 and 4. So we're guaranteed there is a 2 in one of those 2 cells. This sees... okay, so this must see 4 cells that are... 1 eliminates 1 here, so that's 2. This sees 1, 2, 3 cells that are smaller than it. And then 4th here. This sees 1, 2, 3 cells here. So then this must be higher here. This is higher here. This is higher here. That works. And this is higher here for the 3. This is higher here. This is obviously higher than these digits here. Okay. This must see 7 or 8. This must see 7 or 8 in its row or column. And we have a 5, 6 pair left here. So this has to contain a 1 or 2. And it could be with 3 or 4. Or 4 and 5, we don't know. So that means in the rest of column 8 cannot be 1 or 2, because one of them's here and the other one's on this arrow. Add up to 5 or 6. The remaining digits in column 8 then are 3 through 9. No 3 here because we have a guaranteed 3 on this arrow. No 3 here because we have a 3 in the row. Okay. Remaining digits in box 6 are 3 through not 3 through 9, 4 through 9. But we don't really have much information. Oh, these 2 digits, these have to be different 7s and 8s. So therefore, both of these cells will see a different 7 or 8 in these 2 cells. So they cannot be 7 or 8 here. Okay. This can't be 1 or 2. Because of 1 or 2 in the row. Remaining digits of row 7 have to be 3 through 9. So obviously no 3 there. Where is 1 then in box 7? Can't be here, can't be here, can't be on the circle, can't be here because of 1 in the row. So 1 has to be there. Interesting. Where is 1 in row 9? It must be one of these two. Column 6, it has to be one of those two. And box 9, or box 3, it's one of these 5, which is kind of broad. Okay. Column 5, 2 is one of those 3. This sees 2, so everything is blocked, so that's done. 1 and 1. 5. So this sees that, which means that's smaller. Um, this can't be 5, 6 because of the 5, 6 pair in the column. Remaining digits in column 1, we have 2, 3, 4, 7, 8, 9. Obviously no 2 here because of 2 in the row. So to see 5, okay. The ones in the corners have to be able to see at least 1 digit in both directions. Because if it doesn't, it's only going to have in the same row or the same column the digit minus 1 digits that are smaller than it. So it must see then, this must see 1 going that way. For this all 4 of these are going to be smaller. We don't know about that. This digit... So 4 is already done. It sees 1... 2 is done. It sees the 1 here and the 1 here and doesn't see anything past these because they're bigger. Let's just fill out the rest of box 5, 5 through 9. 3 is done. It sees 1 and 2 here. Does not see anything here, does not see anything there, and it sees the 2 there, and then is blocked. 4 is done. It sees the 3, 1, 2 this way. It's blocked here, here. It sees the 1 this way, and then is blocked. So those are finished, so we can remove the reds there. This must see at least 1 that way. Same with this. Can this go that way or continue that way? I think the answer is no. Right? If this... What's the most it can see this way is probably the question. If this is 5, it can see at most 2, 1, 2, 3. So then this would have to be seen. If it's 6, it could see everything plus 4 and 5. So that's 4 cells here. So if it's 5 here, it would only see 3 cells because you can only see 4 here. You can't see 1 or 2, 1, 2, or 3 here. So it'd see 4 cells. It would have to see another 2 that way. If it sees 6, it would have 4 and 5 at most this way, which is 4 cells at most seen that way, So it has to see 1 and 2. So it definitely has to see these digits, which means this is a 3, 4. We now have a 2, 3, 4 triplet in the box, which eliminates 2, 3, 4 in the rest of the box. So this cannot be 3, 4. Therefore, this becomes 5, 6, 7, 8, and 9. And if this is not 6, if it's 5, it only sees these 3 cells because this is smaller than it. So it cannot be 5 here because this would be greater than it, so it's just see 1 cell, 2, 3, and this would be greater, so that would only see 3 cells, which is not valid for the circle. So this must be 6 here, which makes this a 5. That eliminates 5 on this arrow. It eliminates 5 in the row. 6 eliminates 6 here, so this is 5. And this would see 1, no 6 here. That sees 1, 2, 3, 4, 5 cells. That eliminates 5 in the rest of the row. And it could see 1 more here or 1 more here. And it does have to see 1 of them. We don't know which, though. Okay, so this sees 5. Okay. Oh, this is 2 and 4, adding up to 6. So this must be 2 and 4. That 2, 4 pair eliminates 2 and 4 in the rest of the box. So this can't be 4, it's 3. That means 3 eliminates 3 here, so that's 2. Which means this must be 2 and 5, adding up to 7 here. That eliminates 7 in the rest of the box and column. This 3 eliminate 2 and 3 eliminates 2 and 3 in the rest of the row. We have a guaranteed 2 in one of these 3 cells. Okay. So we see 5 there. So one of these 2. So either this is a 4 or this is a 5. Well, I'm not sure. This sees 1 digit that way. This 7 means this can't be 7. This is 8, which is the sum of 3 and 5. That eliminates 3 and 5 in the rest of the box. And 8 in the rest of the box. So no 5 here, no 8 here. 8 eliminates 8 in the rest of this row. 6, which means this is a 6, 9 pair. That eliminates 6, 9 in the rest of the row and box. So no 9 here, no 6 or 9 there. It's 7. 7 eliminates 7 in the rest of this box. Okay, so the 8 sees 1, 2, 3, 4, 5. Guaranteed. Of these, it has to be blocked by a 9 somewhere here. And then it will see the rest of the cells in the column. So if the 9 is one of these 3, it sees at least 1, 2, 3, 4, 5 cells, which is too many. That's 10. So it cannot be blocked this way, so it must be blocked this way. 1, 2, 3, it sees 4, 5, 6, 7, 8, and therefore that's a 9. So this is 9, that's 6. This must be 9, not there. 9 here, and then it sees all of these cells. So no 8, 9, so that satisfies that. This is blocked here. That means it sees all 3 of those, so then it's blocked there. That's valid. That eliminates 9 in the rest of the box and row. Okay, remaining digits of box 4 are 3, 4, and 8. No 4 here because of the 2, 4 pair in the column. So the 8 is satisfied. So, okay, so 2 is done. 3, 4 is done. 3 and 4 are done. 8 is done. We still have to do 5, 6, and 7, though. Okay, so then We can remove these. We can remove these. This is 9. We can remove that. We can remove that here. So 1 out of these two has to be smaller. 9 eliminates 9 in the rest of the column here. So this is a 5, 7, 8 triplet. That eliminates 5, 7, 8 in the rest of the box and column. So no 8 here. This 7 then sees this way. 7 sees 6 here. So it sees 1, 2, 3, 4 guaranteed. 5, 7, 8, eliminate 5, 7, 8 in the rest of the box, so this is 9. So then it's blocked here. 9 eliminates 9 in the rest of this row, and 3 eliminates 3 in the rest of this row. Interesting. So we see 1, 2, 3, 4. We know one of these has to be an 8. Because this can no longer be 8 because of a 5, 7, 8 triplet in the column. Actually, what are the remaining digits in column 3? It's 2, 3, 4, and 6. Okay. So we're guaranteed 8 is one of these two digits, which means this cannot be 8. Because there's no other place for 8 in row 5. So this sees guaranteed 1, 2, 3, 4. And then at most it sees another 1 here. That's 5. So it needs to see 2 more cells. So this has to be able to be seen that way. So this is a 3, which makes this 4, which makes that 8. So this sees 1, 2. So 8 is blocked here. That's 1, 2, 3, 4. 5, it must see another 1 here. That's 6, then it's blocked there. So then this has to be 5 here. No more 5 here. And this can't be 7 because of 7 in the column. So this is 8 or 9 here. So then the 6 is done. So we can remove all of these related to it. We don't need that. We don't need the 1 anymore. Don't need this red. So this is 1, 2, 3, 4, 5, 6. Remaining digits in column 2 are 5 and 8. And this can't be 5 because of 5 in the row. So this is 8, which makes that 5, which is seen here. So that's 1, 2, 3, 4, 5, 6, 7 cells that are strictly smaller. Therefore, this must be blocked here, and then this is done. So that makes this an 8, which means this can't be 8 here. So the 7 is done. We can remove all of these coloring. So the last one left is the 5. 4 eliminates 4 in the rest of the column. So this is 2, 3, 6 as a triplet. 8 eliminates 8 in the rest of the column here. So it's 4, 7, 9. 5 has to see 5 cells. Let's do remaining digits of column 9. We have 1, 2, 3, 4, 5, 6, 7. Oh, no 5. 4, 6, 7. Okay. This has to be seen, so it's 1 through 4. Okay. If we have a digit seen this way, the problem is there are no other digits in this box that are smaller than it. The smaller than the 5. Because these 4 digits would have to be smaller than the 5, therefore this one must be larger. So if we see that way, it's 1, 2, 3 at most, which means this sees only 4 cells because this is larger than it. So it cannot go this way. It must go this way. And therefore, this is smaller than the 5. So this cannot be. So this must be greater than the 5. It's 6 or 7. We have a 4, 6, 7 triplet in column 9, which eliminates 4, 6, 7 in the rest of the column. So it's 1, 2, 3, 1, 2, 3. This can't be 1 or 3 because of 1 or 3 in the row. So that's 2. That eliminates 2 here and 2 here. 2 eliminates 2 here, so that's 4 and 2. That eliminates 4 here. Okay. This has to add up to 5 with this cell, so it must be 2 or 4 here. This is blocked here, so it sees 1, 2, 3. It must see 4, 5 here. Which means these are 1, 2, 3, 4, 4 in row 9. And then this is blocked here. That eliminates 1, 2, 3, 4 in the rest of the row, so this can't be 2 or 3. It's 6. This can't be 4. It's 7 or 9, and we have 7 or 9 here. But this can't be 7 because of 7 in the column. So this is 9, which makes this 7. There's no 7 here, and then the 5 is done. So then we don't need any of these. We don't actually need any colors anymore. And the rest should be done somewhat from normal Sudoku. This can't be 3, 4, or 5 because of 3, 4, 5 is the 1, 2, 3, 4 quadruplet in the box. This can't be 2 or 3, so that makes this 1, 4 as a pair. This can't be 1, 4, so that makes that 2, 3 as a pair. Okay. Remaining digits in box 3 are 6 through 9. Okay. This must be blocked here. So this cannot be, well, obviously can't be 1, 2, 3, or 4. Remaining digits in row 8 are 5 through 9. No 8 here because of 8 in the column. No 5 or 6 here because of 5 or 6 in the row. Remaining digits of... Let's do column 4. We have 4, 5, 6, 8. No 5 here because of 5 in the row. 9 eliminates 9 in the rest of the column. So this is 8. That eliminates 8 here. And 8 in the rest of the column. And 8 in the rest of the box and row. 6 eliminates 6 in the rest of the box here. Remaining digits of row 9. We have 1, 3, 4, 7, 9. Obviously no 1 and 3 here because of the 1, 3 in the box. No 4 here because of 4 in the column. Remaining digits of column 5. We have 2, 3, 5, 6, 7, 9. No 5 here. No 9s in this box because of 9 in the box. No 5 here because of 5 in the row. Remaining digits of box of column 6 are 1, 4, 6, 5, 6, 7, 8, 9. No 1 here, obviously, because of 1 in the row. No 5 here because of 5 in the row. So these 2 digits have to be the same as those 2 digits there. Okay. Yeah, everything was satisfied for the circle, so that's fine. So yeah, the rest should be just normal Sudoku. Obviously you have the arrows mixed in a little bit, but that's it. So these two digits are exactly the same as those two digits, which means they're the same as 2 out of those 3 digits. Huh. Okay, let's mark these. So this is going to be different than this cell. Wherever the blue is must be one of those 2. Which means it cannot be here, so it must be one of these 2. Okay. Not too helpful. The orange has to be one of these 2 here. Don't know which. That's not helpful. Seven has to be one of these 2 digits there. Ah, 3 here eliminates 3 here. So this is 5. Okay, that helps. This cannot be the blue. So this 3 eliminates through 3 as a pair, adding up to 5. So it's 1, 4. That eliminates 1, 4 in the rest of the box. So this can't be 1. This is 3, which makes that 2. That means this is 3. So this 1, 4 pair eliminates 1. 2 eliminates 2 here. So that's 1, which makes that not 1. So that's 2. 3 eliminates 3 here. So that's 1. 3 can't be here because of 3 in the column, so where is the 3? It has to be there. We don't need the colors, actually. So that leaves a 3 here. That 5 eliminates 5 in the rest of the column. So 5 is one of those 2 digits. 2 eliminates 2 here, so that's 3. That eliminates 3 and the rest. 3 eliminates 3 here, so that's 2, which makes this 3. That eliminates 2 and 3 in the rest of the row. So where's the 2 in column 5? It has to be here. 9 obviously eliminates 9 the rest of the box. This digit, these digits are different, so let's make that pink and medium, so therefore that makes that pink. That eliminates 4 in the rest of the column here, because of the 1, 4 pair, which means where's the 4 in row 9? It has to be here. So 4 eliminates 4 in the rest of the column. That means this can't be 4, it's 1, which makes this 4, which makes that 1. So no more 1s here, and no more 4s here. Okay, I guess we didn't really need those colorings either. 4 is one of those 2 digits. Oh, this has to be... Well, no, the 8's blocking it. Okay, never mind. So that's done. We don't have to worry about that. I think maybe we should just double check. The 2 sees the 1 and the 1. It's blocked by 3, 7, whatever these digits are. So that sees 2. 3 sees 1, 2, and 2. Then it's blocked by all of these digits, which are greater than it. 4 sees 1, 3, 1, 2. Blocked by 8, 7, whatever that digit is, and 8. 5 sees 4, 2, 1, 3. It sees 3. It's blocked by 6, 7, and 9. 6 sees 1, 3, 5, 2. It's blocked by 8. Sees 2, 5. It's blocked by 8. 7 sees 3, 1, 5, 2, 6, 4, and 1. That is 7 cells. It's blocked by 8, 9, and 8. And 8 sees 2, 1, 3, 4, 7, blocked by 9. Whatever these cells are, 2 and 1, and it's blocked by 9. So those are, yeah, that's still done. Yeah, this is a little tough. I'm not sure how these disambiguate necessarily. What about these? We'll make this yellow and we'll make that blue for the 7, 9. The blue one cannot be here and can't be any of these. So the blue has to be one of those two, which means the blue has to be one of those two. The yellow can be here or one of these two in box 2. We don't know which. So the yellow has to also be one of those 3. Cannot be here, so the yellow has to be one of these 2. Then obviously this is yellow and blue. Does that help us any? I don't think so. Oh, 4 here. Okay, so that's good. I don't know why. I just... 4 eliminates 4 here, so that's 6, which eliminates 6 there, so it's 5. That eliminates 5 in the rest of the box. 6 eliminates 6 in the rest of the box, so this can't be 6, it's 7. This can't be 6 or 7, it's 4. That eliminates 4 there. Where's the 4 in row 7? It has to be here. 7 eliminates 7, and 7 eliminates 7 in the rest of the column, so this is 9, which makes that 7. 7 eliminates 7 here, so it's 6. 6 eliminates 6 here, so it's 4. No 4 or 6 here, it's 5. 5 eliminates 5 here, so it's 6. 6 eliminates 6 here, so it's 7. 7 eliminates 7 here, so it's 8 and 7. That forces this to be a 5 here. 7 eliminates 7 here, so it's 6. No 6, 7, or 9 here, so it's 8. So this cannot be 6 or 8. This is 7, 9 as a pair. This forces this to be a 7, 8 pair there. 6 eliminates 6 here, so it's 9, which makes that 6. 6, 7, and 9 eliminates 6, 7, 9 here, so it's 5. No 5, 6, or 7 here, forces this to be 9. Remaining digit in column 7. Well, 8 eliminates 8 here, so it's 7 and 8. 7 eliminates 7 here, so it's 9 and 7. 9 eliminates 9 here, so it's 4 and 9. What's left here is an 8, and this has to be a 6. Yeah, I just didn't spot where things were basically clearing things out. I should have probably spotted that earlier, but I think I was too busy with the coloring here. So yeah, challenging seems about right. I basically logicked out what these circles had to contain. I just didn't even think about 9 until pretty late, actually. But yeah, you can't have 9 in a circle here at all, because it will see 17 cells or 16 cells smaller than it in guaranteed in its row and column, so it can't be equal to that. Those numbers seem. So if I think I had spotted that, well, I mean, I didn't spot it that late, but it was, I don't know. Everything flows from that, though, because you have to have 2 through 8, then, which means 2 has to be there. Then 3 had to be at certain spots. So, yeah, interesting little puzzle. I don't know if you could do very much more with this rule set. Maybe, well, yeah, I don't know if you could do more with this rule set. It's interesting. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.